Hello everybody. Today I'm going to be going over a hadron and what they are. And the reason for this is, well, there's many reasons, but one of the biggest ones is to understand photon confinement, and you could say the beginning of time and relativity itself, because I do believe that neutrons, a type of hadron, were the first relative particles that existed. And there's plenty of evidence for that, and I can go over some of it now, but the main thing I'm trying to resolve in this video is what gluons are. And we have to understand what hadrons are first to understand how gluons emerge. So gluons aren't actually particles in my model. They are vacuum energy. And how they come about is the process of photon confinement and three particles trying to use the same space. So you could say they originate as a confined particle in photons by photon confinement. So two photons colliding with enough energy, they produce a neutron and antineutron, and obviously all the helicities within that. But what's happening is first it's a particle, and then it expand like those. Due to the internal vortices, something overcomes another aspect to it, and it causes a triple vortice. And this may be the result why they have 1/3 charges, is because they are still two photons orbiting around all three of these in almost like a zigzag pattern, like not a zigzag, but like a wave around it in three different waves. And there are basically three particles that are all using the same space, and they become photon confined separately, and yet they still have a way of communicating, you could say, or like they're the flux tubes of transferring between them, or they might do so through the vacuum. Either way, that isn't necessary to understand what I'm trying to say, because all that's necessary to understand, they use that same space, and I have a picture of it. So when you look at this, we'll zoom in more. Okay, so this top right one with the black and yellow. So you can imagine these three photon confined quarks, and then the shared space between them. So this would be the volume that they would occupy if they didn't separate, would be the area in which the gluon vacuum space is. We derive what that space is. So we'd first get the size of a hadron, reduce it to three perfectly compacted spheres within it, and then we'd find the volume of the circle that overlaps the middle of all three of them, because this would get us to around what the volume of all three of them would be if they were collapsed in on each other. So they're shared, you could say the shared volume. Okay. And then what we do is we assume that entire space is vacuum energy. And it gets us pretty close to almost exactly what the vacuum force is. So let's walk through the process here. So first, photons, in the beginning of time, photons enter confinement with each other, creating neutrons and antineutrons. And I'll just walk through this quickly so we get to it. And then neutrons and antineutrons decay into positrons, antiprotons, protons, and electrons. And then the universe, for some reason, decided to, there was a mechanism behind it we don't understand yet. It annihilated all these protons and positrons, or antiprotons and positrons, into electron neutrinos. And that's why we get at least close to the amount of electron neutrinos we have in the universe. And maybe it was just a flip of the coin. Maybe there was a mechanism behind the decay rate of antineutrons, and maybe it's a slight difference between the two. And if that's the case, then we know that that's the reason why we have matter over antimatter, is actually the decay rate of neutrons was happened much more quickly. And that when these particles annihilated, because obviously just from the result of decay, neutrons would create electron neutrinos from decay. So proton, positron, antiproton, and electron neutrino. And then from them annihilating, well, where would all that mass go? So if you had an antiproton and a positron and they annihilated, where does all that excess mass from the proton and electron go? Because mass doesn't annihilate. So it would go all into electron neutrinos. And this is why they have opposite, they maintain all the other factors. So the helicity, and all the other stuff, it's converted into other things or electron neutrinos. Okay. And this is the reason why we have a symmetry between protons and electrons, is because they all stemmed from neutrons. So there would be an obvious, and it's also how a photon could be responsible for two charged particles. But I can go into charge more in depth in another video. Right here, I'm just trying to articulate, okay, these things came about by this process, so we know they're photon confined. So photons made these two types of charged particles, electrons and protons, and then I'll go into those in another video. But right here, I'm trying to explain the process by which we can get to the energy of the strong force, which is just vacuum energy, through deriving the volume of the shared space between three quarks, because that's my assumption. And if I get very close to it, then I know that it's just subtle differences. Like maybe the flux tube have a certain volume that is no longer applied to the strong force, and therefore we just subtract that volume from the equation. But either way, even without any of that, even without any other thinking about any other structures or any other aspects to this, all I'm doing is very simple geometry. So you just take the size we expect a hadron to be, which is the one that I'm using right now. So this is 1 times 10 to the minus 15. And obviously, because of the nature of Heisenberg uncertainty principle and true dichotomies, etc., it's impossible for us to have an exact measurement of the size of a neutron, but we can get more accurate with it over time. And we'll eventually do so when we get enough data and we see the context. Like you can say, if we measure enough of them, we'll get a standard deviation and or a bell curve, and we'll just go with the average across the most contexts, because then it would be like, okay, regardless of context, it seems like most of them fall into this range, regardless of how much energy or how low of energy interactions we have. We could just go with the average, because that would that might make the most sense. Or it might just be the lowest, which would be like the smallest interaction, because then it would just show that it's just like pushing on your skin, right? Like your skin deforms the more pressure you put. But if you were to say, well, how big is your arm? You wouldn't push in, you would just barely tap the edge, so you can see this is exactly how far it is. So you just put the ruler up to the edge, or across the edge. So, okay. So first, let's just go with this. This is not perfectly accurate, but this is my assumption for now. So we have 1 times 10 to the negative 15 for its electric field. Its magnetic field would be slightly larger than that, but we're going with the size of the electric field, or the physical interaction we would have if we were to touch a hadron with our physical hand. So based on 3 circles compacted into the hadron, we estimate the radius of the quarks. So again, it's like packing Coke cans next to each other. We would just get the radius of each quark, and then we would see how much volume that is. And we estimate its radius to be this, which is 4.62 times 10 to the negative 16 meters. And obviously up and down quarks have different sizes due to their mass, which would, change the size of the electric field, you could say. But for the sake of this simplicity and to show that it almost gets us there just with this, I'm just going to use this and make it so super simple. So like there's no confusion. There's no me having to justify like how I actually got to the size of each one of these particles. It's just strictly from hadron, developing 3 perfectly in sync spheres that overlap with the hadron, and then deriving a sphere that intersects with the 3 through the center of them, and then saying, okay, well, what is that radius? So this would be the radius of the gluon vacuum. And then this is just a picture representation of everything I'm doing. And then we would calculate the entire gluon vacuum as if it was all just vacuum energy. So we're saying this radius of this sphere is all vacuum energy. Now, what would that be? So it gets us to 2.86 times 10 to the negative 10 joules. So this is how much would result just from the calculation that I derived. Now, obviously, I've taken out our current estimates of the flux tube, and it gets me to under what this is. So maybe either our estimations of what the flux tubes, how big they are, etc., maybe misunderstood. You can almost think of this as one particle, like, and that's kind of how I think of hadrons. Like currently, they are one particle, but they're in three distinct parts that make up the whole. So they are each individually photon confined, or they may just be totally photon confined. So we can imagine the photons going out around the edge and just constantly spinning around it. Or we can imagine that there's three separate pairs of photons. Either way, like this is hard to perfectly conceptualize, especially since the inside of these are likely there is the chance of them rotating in opposite directions. So then we would have to understand like this being the result of photons just going in random direction, not random, but in different directions, and maybe even random directions. And this is the result of what we're calling color confinement, which is really just them transferring the photon into each other over and over again to change their helicity. And this would make sense. I don't know why we have to develop all these weird abstract concepts to derive something that is still classical. Okay, so anyways, that's the estimate I have. So what does this mean? So I'm within, what did you say, like 2 times what we calculate it to be? So this is the current calculation of how much joules is acting on all three quirks simultaneously. Like how much pull is that strong force having on these quirks? And obviously this gets stronger the further out you go. So another possibility is that even the slightest size increase in this. So like even if I just included one up quirk in here and it was slightly reduced radius, this would have a disproportionate effect on its vacuum energy. So this may be the major contributor to that. Another one might be the the flux tubes, microtubules. The flux tubes that connect these three. So, and that's kind of why I lean more towards photon confined being an external thing where the photons are rotating on the outside, is because not only are they 1/3 charge each or operate within thirds of charge, but they also have this flux tubes which connect them, which I think would be the result of photons confining them together. But it also might just be the vacuum energy trying to reconcile itself. And interestingly, Terrence Howard's shape kind of emerges from in between quarks, the tetrahedron, or the curved tetrahedron, I should say. And I would say that there's probably some merit in that he could call it the flower of life. But it's just like it would be the vacuum energy, or the vacuum, or like shape of a gluon, you could say. Even though the gluon sphere of influence would be the result of these confined circles. So, in showing a relationship between two figures, the vacuum estimate within one order of magnitude. So, the proximity and the fact that we know the strong force increases with distance, and the fact that eventually the distance leads to decoherence, decay, or state changes means that this is likely the best explanation of what the strong force is. So it's not like we've been trying to formulate that each particle has its own associated field, and all these fields interact in different ways because they have different properties and different characteristics. But no, what I'm saying is like this would unify it all. It's a classical understanding. And some of the aspects that quantum mechanics has to offer, which are, you could say, like good things, I explained in other videos, like the particle wave duality, and how everything is a particle and everything is a wave simultaneously. And you can't have, what it basically is you have a wave, you could say, and it's resolving in space through constructive and destructive interference. And that's actually how it gets to its actual final resting place. And just because we can't predict exactly what it's going to destructively or constructively interfere with, doesn't mean that it's always going to be acting as a wave. But it also can't ever exactly act as a particle, even though it transfers all of its energy at a single point, which would be just the photons, either in the particle or whatever it is, transferring all that energy at that point. It doesn't necessarily mean that the thing itself is a point. It's almost like when my two fingers touch, like at some point, at some moment in time, they're going to connect, and it's going to do so at an exact point. Or you could, that would be the rationalization, but it's at least Planck length and width is the first connection. Because obviously if it ever resolved at an exact point, there would be an infinite amount of energy that every touch would have. So any touches around you or anything, if it ever resolved at an exact point, there would be infinite energy, which is why quantum mechanics is wrong. The other formulation is this idea of duality itself, like binary duality, not the spectrum which I'm offering, is that it's a wave. It can be more of a wave until it reaches all wave, which is like across the entire observable universe, and then it can be refined into less of a wave or more discrete or more particle like, and it'll get as close to that as possible. And then we can still measure its characteristics by the way this space-time energy interacts, but it's still just that. It's still this underlying space-time and energy, which is the unifying field, so to speak. So the field is these three characteristics, and it's just the interactions and compromises between these things. And I can go into that in another video as well. So now we've derived how we can get to the gluon vacuum energy, or at least a very close estimate or approximation of it, just by using that space and assuming it is all vacuum energy. Like obviously we would want to get as close to exact as possible with this estimate, but I don't have access to the information that would derive or help me figure out this conclusion. So like obviously we would need to do more accurate assessments of how much volume there is, because I don't think like we even really care that much about how much volume these things have. Because it's like, well, what is, if I do figure out the volume of a quark or whatever, like what does that actually do for physics? It doesn't seem to really help anything. But under photon confinement, this would actually be incredibly important, because I mean obviously it unlocks new types of physics that we can do, and the way we can understand the interactions, and it gives us a deeper understanding, and there's going to be so much treasure underlying all this. And that's why I think it's important to understand exactly what these dynamics are, and including spin, including like, which I also think quantum mechanics has wrong. I don't think the understanding of spin is correct. All these things that aren't tied to a physical thing we can show an example of, I don't think they're true. So for example, if I'm spinning the Earth, this gives me a physical representation of what spin is. But in quantum mechanics, it abstracts spin out to this new dimensional layer. Then we say, well, it's spinning and doing this thing. Well, what is that thing that it's actually doing? It's like, well, it's doing the thing that it does and things. And it's not a really good explanation for the physical nature of it, which is what physics is supposed to be. It's like you're explaining something physical, but you're just using this abstract process. And then the idea of like particles being the only mediator is photons in my model. Photons mediate every interaction. Because if it's a relative aspect, which we are relative beings, and we also have non-relative aspects, and that might be consciousness, but that's for a whole nother layer of thinking and for another time. But when we think of every interaction, things they're just transferring photons or integrating photons, or the kinetic energy is a result of energy transfer of photons. And when we think of it this way, it simplifies things and understands the underlying mechanism behind them. It's kind of like saying, like, when humans are interacting, are we using a different force, or uh, are we using the molecules within us? Are we using the cells to provide us with energy? And it's every layer all the way down. And then the bottom layer is the thing that's providing all the contexts and in the mechanism for which all interactions happen. So, like, I mean, obviously there might even be something under photons, but this is currently how I understand the interactions to start. So currently it's photons. It might be something deeper, it might be a little more layered. But let's just think of it like this: if like a person punches someone, well, you're using the flexing. You're sending a electrical signal with electrons or and the other mediating electrical pulses, things that mediate electric pulses through your body and through your muscles to do that action. And that requires your cells to produce ATPs through metabolism and stored energy in your glycogen stores. But where does that stuff come from? Well, it comes from the molecular energy. And where does the molecular energy come from? Well, the atoms are exchanging electrons, and that's what's converting that energy. And then, well, what's happening on a deeper layer? Well, what are those electrons convert? Like, what do they convert into? Well, they emit and transfer photons to each other. And then you're like, wow, all of a sudden everything becomes a photon exchange. But here's the strong force, and that's how it's connected to all of these other things. So all hadrons have this strong force as a result of photon confinement, and these particles trying to utilize the same space to manifest their identity. So you can, like, this even happens with quarks and antiquarks. So you have the mesons, they have the same space, and then what's happening is they get photon confined, and they resolve the different aspects of, you could say, turbulence or fluid dynamics. And so for some reason, I have to go into understanding not quantum mechanics, but fluid dynamics and turbulence and eddies to understand how these things happen. What is the force that's binding these things together into a whole? And then what is being overcome to divide them into two separate parts of using that same space? And once we understand that, then the rest kind of falls into place. And that's how you get a trisphere. It's like, well, under what fluid dynamics or turbulence or, even air, in what context do trispheres emerge in vortices and eddies? And once I find that out, then I could say, okay, well, this makes sense. And it's very interesting, because if two photons collide and they make a neutron and antineutron, like, one will have two vortices going, right, having a right-handed helicity, and then the other one will have the left-handed. But the opposite will have two left-handed and one right-handed. So this is how photons in the beginning of time had to be the case, because they maintained symmetry of all these aspects: helicity, energy, charge, etc., etc. And so neutrons obviously have a neutral charge, but then once they decay, that process of decay somehow either flips the orientation of the photons inward of its electric field or outward. So this would lead to positive or negative charge. And it may be that neutrons are neutrally charged because all of the orientations either cancel out of the electric fields to make it to where it doesn't have a charge, or it's not oriented inward or outward, which would mean that it's along its plane, and it would still generate a small magnetic field. And this is what I'm trying to figure out with the EM field, as well as figure out how they manifest. Like, in which, if I have for instance, I'm going to go into so much more stuff. All right, I need to slow down. All right, so I really appreciate you guys watching. So this is how I think the strong force came about. The mechanisms and the process is classical. there is no superpositions. It's just our inability to measure the interactions. So, like, again, I'm not going to go into this. I appreciate you guys watching, and I hope this gave you a better understanding, or is getting us closer to a better understanding of what these forces are. Because I am trying to reduce things to the smallest necessary components in order to properly understand them. And one of the biggest things for me is like, well, if we start with 4 forces, where do these forces come from? And then I'm just reducing them. So, okay, well, is vacuum energy a force then? And then, well, maybe. But I don't think we should call it the strong force then. I think because we already understand vacuum energy to be a thing, and maybe this is what is holding things together, from like not like any space from not having any energy. Like you could say, like there's always a vacuum. There's a certain amount of vacuum that is being overcome and compromised with everything else. So like if we're generating a specific area, like where the Earth is, everywhere around it, besides obviously the moon, we call it empty space, but there's still energy there, which means there's still mass there. And basically you would have to get to a massless or energyless area of space. If you can get to a massless space, you can get to an energyless space, is what I'm basically saying. Because in order for us to have a space absent photons or absent mass, it would require an area where there's no interactions happening at all. And because the very nature of reality requires there to be interactions, we would get rid of relative reality by removing all interactions in a given space, all relative interactions, because I think it would be impossible and it would require infinite energy to achieve that. We are stuck and bounded between these two extremes of absolute zero and Planck temperature, and I think they emerge out of photon confinement and photons interacting. So you can reduce all of relative reality to Planck's constants, and Planck's constants all emerge from interactions between photons, because photons, I think, are the fundamental unit of energy, and we may have something that photons are made of that are smaller, but like I said in another video, it would have to be along the relative aspect of its wavelength. But so I've already gone over photon confinement. Now I've gone over hadrons, which were the first manifestation of photons in the early universe. So I don't think it might have been possible for electrons and, let's say, electrons and positrons to exist, but then they would just annihilate. And the other thing is photons alone cannot be responsible for creating electrons, because it wouldn't remain symmetrical across charge. Well, no, not charge. So it would be equal across charge. I gotta look this up now. It wants me in free space. So we have to understand, under the context in which photons collide, there has to be under a certain context. So like there already has to be like an atom there to help process this information or to absorb the excess energy. So right here it's saying the nucleus is required. So this would require it to exist before electrons could exist. So electrons couldn't exist unless a nucleus exists. So this means, in reality, it was impossible for electrons to exist unless we had a nucleus. So it wouldn't even be able to convert into electrons. So we know, according to our model over here, or our entire diagram of all the aspects of particle physics, that, let's see, stable or unstable, where are you? So here we go. All of our stable particles are in the top right here. So the top, and this one's a gluon, it's a spandrel. This one is an electron. Okay, so we get rid of all the neutrinos because they are the result of decays and other interactions. They are like, you could say, the leftover garbage. Not, you can't call it garbage, but they are the leftovers of processes of interactions. And then you have up quarks and electrons and down quarks. So that's all that would be left after that. So you get rid of gluons, you get rid of, I mean, you don't get rid of them. They're still important. I'm just saying in terms of the early universe, neutrinos couldn't exist because they're the result of interactions already of particles and decays and stuff like that. So this would necessitate the particles exist. Gluons are the result of photon confinement. So they couldn't exist until neutrons exist. Electrons couldn't exist until neutrons exist. Protons couldn't exist until neutrons exist. And then up and down quarks obviously can't exist until neutrons exist. So then, well, what's left? Well, what made neutrons? And the answer is photons. Photons made neutrons and antineutrons. And I should have probably put this in my initial video, photon confinement, but I think it's more important that I do this when I articulate the full story of our story, which begins with photons, or you could say God or the universe saying, "Let there be light," and it happened. And so there was light, and that was the first synthesis. And then light manifested into all derivations, but it couldn't. You could say it made electrons, and it's not possible. And that means there couldn't have been charge symmetry because there's no other particle for it to manifest, because all other particles would be, it wouldn't be able to make these spin 1/2 particles according to our current model anyways. But even then, like, it might be possible. I don't know what symmetry it would break if it was trying to manifest, let's say, what would you say, like a muon or tau, but it would probably break the same symmetry as an electron. And they're very unstable, so obviously they couldn't be the result of anything, and they don't mediate any forces according to the current model. But this would mean that, like, muons and taus are basically just turbulence, and they don't really have any particular reason for their existence, you could say. But they're used, you could say, like, they're used as ways that things interact at a certain level. Regardless, this is how I got to the conclusion that photons are the fundamental aspect of reality. Is like they give rise to all these other features through the way they interact and the turbulence they create and the way they confine each other and the way they orient their charges, their helicities, change the spin orientation. So all this is classical stuff, and that's what I'm going to show to be the case. And I'm really excited about it. Like, the more that comes out about it, like, the more, I mean, obviously the harder that the questions become, because, like, obviously if having the intuition just pop in your head is like, oh yeah, this sounds like it's a connection, but then actually doing the legwork and figuring out all the mechanisms is difficult. Like, I've got a pretty firm understanding of spin. I've got a pretty good understanding of charge, and maybe that will lead me astray, but we'll see. But the hardest part right now for me is understanding the fluid dynamics of when a trisphere would emerge. So, like, that's what I need to understand with hadrons now. So, like, if anybody out there understands physics, this is currently, and you think that there's truth and merit to what I'm saying, then like, if you can help me, or like comment or send me a message, just help. Like, I need help understanding like, under what context these trispheres would emerge in the vortex. And I mean, I'm going to be doing my own research, so maybe you can just have a chat about it. But this is still how I think of it, and it has implications. Let's see. Well, let me just read this, and then we'll just end the video there. So the implications of this are firsthand evidence that we have been rationalizing just so stories in physics and attempting to reconcile answers by making assumptions that are leading us away from the truth. Quantum mechanics has some truth and answers, but it fails to remain consistent with any kinds of physical relationships. This is because fundamentally it is attempting to explain the characteristics of particles, and rightly so, but it fails with regard to establishing how the relationships between particles unfold, and we begin to rationalize things like W bosons being the mediator of exchange because they are bosons and because they have charge, but it must pop into existence, exchange a charge, and then disappear, almost like a whimsical fairy granted a wish. This is nice and might work out, but it is because you're doing the same thing as saying transferring helicity and other aspects of photons into these particles and reorienting its charge. But because the particle is either unstable or such high energy state, it ends up decaying immediately. But these high energy collisions result in these particles as a result of turbulence and overcoming of forces to generate a temporary vortex containing the energy, the charge, and all the other aspects of it, and thus photons for a brief period. It just so happens that the fluid dynamics will show that there are thresholds to space and how it transforms via turbulence in relationship with photon confinement. But since photons mediate all these interactions, it's likely that the turbulence is a temporary and unstable confinement of photons in a particular orientation or characteristics. So this is my argument of why quantum mechanics not only has it wrong, so it has things right, but it has particular things wrong, and mostly it's articulation. So like some of the metrics are true, some of the calculations might be true, but most of it is in articulation and how it's actually what these things actually mean in physical reality. And there are some rationalized equations, some rationalized calculations that are just formulated wrong. It's kind of like what I was saying earlier. If you just assume the entire hadron is the vacuum energy, like maybe you can even get to the right answer in some of these things, but then it would likely that you're getting to the wrong answer as a result of what you're actually trying to measure, or like how you're actually trying to delineate what you are measuring. And this is where I think it would fail, especially if you scaled it up and tried to apply it to things that we know to be physical, like a human being. Like we can get within reason of how big we are and say, how much energy does this person contain in them, etc., etc. But obviously, as you approach that level of accuracy of quantum mechanics, it gets really hard. And that's understandable because you're approaching the end of a true dichotomy or an extreme, which is possible in reality. But yeah, I hope this gives a better understanding of what a hadron is, how gluons arise out of them, and where I am in the process of understanding how these things come about. So this gets rid of the strong force. It is not a strong force, it's just vacuum energy. It lends credence to my theory if I can get more and more accurate with it by understanding the different dynamics and structures at play. And then the last thing is that it shows us the physical mechanisms that it is a classical reality we're dealing with here, and it doesn't all of a sudden switch at some level of analysis from being classical to unclassical. It's that even the things that quantum mechanics have revealed to us at the large scale just so happen to be at the small scale as well, and the large scale. We just didn't see them at the large scale, and now that we saw them at the small scale, those truths, now we see that they manifest all the way up. So like the idea that we are particles and wave in a duality, it's like, but we're constantly being resolved and constructively and destructively interfered with everything around us. But if all of a sudden space was dissipating and like in such a way that like accelerated in an accelerated way around us, there's nothing for us to destructively or constructively interfere with, then we just disappear almost in a way. Like our entire being just vanishes in a way. And obviously this would probably happen at like black hole. It was near us, but like that's just the way to think of it. Like we are literally in a relationship with everything around us in this way that gives us our identity and gives us a place in space, time, and energy. So we live in a relationship to this, the entirety of everything. So all at once, we're in a relationship with everything. But those relationships have to be delineated, because I can't have a physical interaction through my electrostatic force or electrostatic field or even electromagnetic field with, in the Andromeda galaxy. But the energy I contain in my gravity can permeate the entire universe, and my energy acts on everything in that way. And much like a true dichotomy is like, they encompass all of reality. So if it is all of reality that is encompassed by this thing, everything resolves on a relationship scale across these true dichotomies. And this is why I think nothing can have the exact same energy, nothing can have the exact same space, and nothing can have the exact same time. And that's all there is. So if something can't have the same space, can't have the same time, can't have the same energy, then we can be differentiated. But we all rely on these true dichotomies to give us our identity. So it's almost like potentiality is the entire spectrums, and then it actualizes into actuality across those things, which is like the other extreme. So like we can't be completely the true dichotomy, and we can't be completely the synthesis. So we as beings live in between this, in a compromise between those perspectives. And that's exactly what my framework says. It's like true dichotomies resolve into a synthesis. But we also have to remember, every time I'm going to start to caveat this, because a true dichotomy doesn't mean it's binary. A true dichotomy is only binary at the extremes, and it gives rise to the entire spectrum, relational spectrum in between. So we things can only be hot or cold relative to something that's hot or cold. But you can't be relative to absolute hot or absolute cold. Or sorry, you do still have a relationship with it, but it's not like those things exist in physical reality. So that's the best way to formulate it. You still establish relationship with the thing, with a true dichotomy, but we live in relative reality, or the spectrum that emerges from those two concepts being in tension and compromising with each other. So they're in tension and they resolve the tension. And that's how I think the whole universe operates. But all right, I can go on forever, but all right, thank you guys for watching. Love you, and I hope you enjoyed the video, because I want people to get the word out. I want people to understand this, and I want to see if it's true. So if it's not true, if we can find a way that's like, oh, this is dumb, then I'll definitely would appreciate it, because then I wouldn't have to do all this legwork for no reason anymore. But it would be kind of devastating, because this all kind of makes sense for a lot of things, like spin. Like obviously spin is the result of photons interacting and changing its helicity, which would change its dipole moment. But all right, thanks guys.